Okay, a good day to you, class. So this recording will tackle on the explanations and finding the answers on our last quiz, which is the quiz on probability. Okay, so allow me to show you the actual slide that we have used for the quiz. Okay, so I'm just going to duplicate it so we could have the original copies soon. Now, um, we recall that when we talk about probability, this is basically just the number of events, okay? Let's say number of events in E divided by the number of events in S, where we say that E is, let's say, the event that we desire or that we look at or that we observe. And then S is basically the sample space. Okay, when we say the sample space, the more common term for this is that this is the um, all, okay? Let me all caps on that, all the possible outcomes of the scenario, okay? So what we usually do here is I can usually say it in three steps. In finding the probability of an event, usually what we do first is we find the number of outcomes in S, and then we find number two, we find the outcomes in our desired event, let's say event E, and number three, simply divide what we got in number two by the number of total outcomes in the sample space. This is the center idea for all types of probability. Okay? Kahit pumunta kayo on the higher ends of probability, this is just uh, the entire idea behind it. Okay, so we dive straight to our first five problems. We have here getting exactly two heads, getting yellow sock, landing on an odd face, etc., etc. Okay, so let's start with number one. So when we say number one, okay, getting exactly two heads when tossing two coins, okay, so we have to look at S, okay. S here is basically just all the outcomes when tossing two coins, okay. In our previous lessons, that is simply just, okay, all the events in coin one multiply by all the events in coin number two, okay. So sa coin number one, we know that this is just two, okay? Two because coin one can be either heads or tails. The same idea with coin number two. Coin number two will also be just heads and tails. So our S here is actually just four, okay? So there are four possible outcomes in this scenario, okay? So if you want to, okay, if you want to list all of them, you can just see that it is when both are heads, when we get heads and then tails, we get tail and heads, and finally we get both tails. Okay, so there are no other outcomes here. There are just four possible outcomes. Now this is the S. But what is the event that we are actually looking at or that we want to observe? It's this phrase. Okay, the event wherein we get exactly two heads. Okay, so in our sample space, what event actually has two heads? That's correct. If you thought that the only event where that is possible is when you get heads and another heads. If you ask, Sir, bakit po walang head, tail, and tail head? Because, again, ang kailangan natin ay exactly two. Okay? Pag isa lang yung heads, of course, we do not count it. That's why our event E here, the event that we desire, is only HH or just one particular outcome. Now, of course, the probability of that event, okay, again, as I told you earlier, this is just you get the number of outcomes that you desire, the outcomes of a desired event. So there's only one outcome there, divided by all the possible outcomes, which is 4. Okay, so 1 over 4. That is the event in E over the event in S. The event in E is 1, the event in S is 4. So this is just 1/4. Or 1/4, if you want decimal, this is 0.25. Okay, so that's the answer to number 1. Okay, so I'm going to delete this one. So again, the answer to number 1 is getting exactly 2 coins. Okay, next we get the answer to number 2. Oops. Okay, so the answer to number 2, okay, here. So I'm just going to delete the number. Okay, so what's important is the problem anyway. Okay, so when we look at here, this problem, getting a yellow sock from a box. Okay, this is actually your event E. This is the event that you want. Okay, containing 8 black socks, 2 yellow socks, and 3 green socks. Now, the question here is, what is the sample space? Okay, so if you look at the problem correctly, you're getting a yellow sock. Okay, isang bagay lang ang kukunin mo sa box. Okay, now that is your event, getting one object from the box that contains eight black socks, 2 yellow socks, and 3 green socks. Okay, so your S is you can get either of the 8 black socks, so meron kang 8, or you can get the 2 yellow socks, which is adding 2, or you can get any of the 3 green socks. So technically, okay, your sample space is 13 possible outcomes. Okay, because you have 13 different socks. Okay, meron kang 13 na medyas sa box na kukunin mo. Now, what you are interested in is getting a yellow sock. Okay? So, ilang yellow sock ba yung nandito sa box? According to our problem, there's only 2. Okay? So, there's only 2 outcomes. You get yellow sock number 1 or yellow sock number 2. So, there's only 2 outcomes. So, by getting the probability, okay, again, the probability of this one is just the number that you desire, 2 over 13, okay, which is in Desmos, okay. My apologies if I'm going to use Desmos here. So let me just get my calculator. 2 over 13 in decimal. Oops. Okay, that is 0 point here, 0.1538. Okay, so this is the answer to problem number 2. Okay, 2 out of 13 because 2 yellow socks out of the 13 possible socks, or in decimal 0.1538. Okay, so let's move on to number 3. Okay, so number 3, both dice. Okay, landing on an odd face when you throw 2 6-sided dice. Okay, so what is the event E here? The event E, yung gusto nating tignan is this. When both dice land on an odd face. Okay? So ano nga ulit yung when you talk about odd, these are numbers that are not divisible by 2. So that's 1, 3, 5, 7. Sa negative side, you have -1, -3, -5. Okay? So that is our E. The question here is, what is our S? Okay? Our E is getting an odd face. What is our S? Our S is again all the possibilities. When what? All the possibilities when you throw a 2 6-sided dice. Okay? You can look at S as all the outcomes without conditions. All the things that might happen. Okay? So when you throw 2 6-sided dice, the events that could happen is, okay, let's divide this again. So you get the events in dice 1. Okay, how many events are in dice 1? multiplied by the events in dice 2. Okay? Just recall that when you are getting the number of outcomes in a compound event or a complex event, you simply get the number of outcome per simple event. Okay? If you forget, if you forgot, this is just n1 times n2 times n3, sorry, this is small letter n, n3, and so on and so forth. Okay? You get the number of outcomes in each simple event and then multiply them. That is how you get the sample space of complex event. Okay? So in this case, when you throw two dice, I look at two dice. Okay? So dice 1 can have 6 possible outcomes. Okay? Because I can get 1, 2, 3, 4, 5, or 6 in dice number 1. Okay, that's actually the same with dice number 2 because dice number 2 I can get 1, 2, 3, 4, 5, 6 on the second dice. So obviously this is just also 6. Okay, so all the possible outcomes in a sample space S is 36. Again, the probability of E, okay, this is just the events that you want. Okay, we haven't figured E out yet, but let's put 36 here. Okay, because 36 is the total number of outcomes. Now, let's look at the odd phase. Okay, when you look at the odd phase, okay, let's say we have two slots here. That if the possible outcomes for dice 1 and dice 2, we want them to both be odd. So how many odd numbers could we get in dice number 1? We can get 1, we can get 3, or we can get 5. Okay, that is 3 different odd faces from dice 1. How many odd numbers can we get from dice number 2? That's the same. 1, we can get 1, which is an odd number. 3 or 5, which are all odd numbers. So how many odd numbers are here? Also 3. Okay, and then since this is a compound event, you simply multiply the number of events here. 3 times 3, that becomes 9 over 36. So the lowest term for this is 1/4 or 0.25. Okay, so that's the answer to the third problem. Okay, 0.25. Next. Okay, so here we look at getting the same number on each dice when three six-sided dice are rolled. Okay, so what is our event E? The desired event here is we want to get the same number from each dice. Okay, that is what we want. Now, what is S? Okay, what will be the value for our S here? How many possible outcomes can happen when what? When we roll three dice. That is our entire scenario. We roll three six-sided dice. Okay? So we roll three events. We look at dice number 1. So I'll just put here D1. We look at dice number 2. And then we look at dice number 3. So dice number 1 obviously has 6 outcomes. 1, 2, 3, 4, 5, 6. The same with dice number 2 and the same with dice number 3. So the answer here is 216. Okay, so there are 216 possible outcomes when you throw three six-sided dice. Now, let's look at event E. So we have three dice here. Okay, whoops. We want them to be of the same number, okay? So how many numbers are there in dice number 1? There are 6 possible numbers there. Now, the tricky part here is this. Let's say I get a number, number 1, okay? If I get number 1, okay, on dice number 1, the others would also have to be 1. I have no other choice there. Okay, if I get number 2 on the first dice, the next ones should also be number 2. I have no choice there. If I get number 3, the others would still be number 3. So if I select any number here from the six numbers here, I will have no other selections for the other dice. It can only be one. Okay? So 6 times 1 times 1, that is 6. Or if you want to list all the possible events that can wherein this can happen, you can do so. 1 1 1 1 2 2 2 2 3 3 3 3 4 4 4 up until you get to 6 6 and 6. As you can see, those are all the outcomes wherein you get the same number on each dice. Okay? So the probability of E, that is simply 6 divided by 216, or 1 over 36. So in decimal form, this is 0.277, 0.0277. Okay, it's actually 278 because we rounded off to the four decimal places. Okay, so that is the answer to this particular problem. Okay, let's look at the last problem here and the first five problems. Okay, so here we select three meat dishes from a canteen selling seven meats, five vegetables, and six desserts. Now, we are selecting three. Okay, that is actually your S. Okay, you select three items. Okay, you select three items from what the canteen is selling. Okay, so we select three. Now, how many choices can we have? Do we have here in the canteen? We have seven meat, okay, plus we have five vegetables, plus we have six desserts, okay. So technically, we have how many selections here? We have 18, okay. 7 plus 5 plus 6, that is 18 selections for three objects, okay. So what we are dealing here is a combination problem because again you're going to select three. It does not matter what you select first, it does not matter what you select last. What matters is that you select a total of three items from the selection or from the choices. Okay, so this is 18 combination 3. Okay, so in our calculator, 18 combination 3 is 18 combination 3 is 816. 816, that is our sample space, everything that could happen there. Now, the event that we are looking for is if we select three meat dishes. Okay, so how do we solve for the sample space of this one again? Select three meat dishes. Okay, remember that when we are solving this one, okay, here are your steps. We allocate the slots per category. Okay, this is not a what do you call this? This is not an empirical step. This is just me uh, telling you how to make it easier. Okay, and then after you have determined the slots per category, you determine the choices per category, and then you you select if it is a permutation or combination, and then afterwards you multiply the the what do you call this, the factors or the results. Okay, in this case, so we are looking at three meat dishes. That means we allocate three slots for meat. Okay, I want you to note that. Now, how many meats are there? There are seven different meats. Okay, so what this implies is that from seven different meats, okay, we select three. This is a combination problem. We select three combination, so 7C and then 3. Okay, that is what you will put in your calculator, with wherein you will get 7 combination 3 is 35. Okay, so this is 35. And finally, the final step is simply the probability of that is The number of desired events, that's 35, over all the possible events, 816, which is, in our Desmos calculator, is this one. This is the lowest term already. But in decimals, it will look like this. 0. Okay, 0429. Okay, so this is the answer. Okay, so those are the answers for number 1 up until number 5. Okay, so next we move on to this particular problem. Select 3 members from a judging committee consisting of 6 artists, 4 designers, and 3 writers. Okay, so I'm going to simplify this one already. So we're going to select 3 members for a judging committee. Now, you must note that there are no special positions here. You're just going to select 3 members. No first judge, second judge, third judge. Just select 3. Okay? So when we're just selecting 3, that means we have a combination problem. So the difference class, again, as I've told you already, permutation is concerned about positions. It's concerned about rank. It's concerned about order or the arrangement. Okay, that is permutation. However, when you look at combination, combination is only looking at the total. Okay, what group have you made? What do they look like in total? This is regardless of their order. Or if all members or slots are equal or the same. Okay, these are the times where you're going to use combination. Okay, so in this case, obviously there are 3 members. All of these members are the same. They are all equal. So this is a combination problem. Okay, so let's first look at S. Okay, so all the possible outcomes here, you're going to select 3 members. This is a combination problem. And then we ask, how many people are we going to select from? We have 6 artists, and then 4 designers, and then 3 writers. So 6 plus 4 plus 3, this is 13 possible choices. When we select 3, we get 13 combination 3. So in our calculator, this is equal to 286. This is our S. Now, we have to ask, are is every item filling in 3 members? Look at this one. Number 6, 3 members. Number 7, also 3 members. It just has a condition wherein no member can be artist. Number 8, consisting only of artists. And number 9, 2 must be writers. And the last one must be a non-writer. Okay? So let's solve for number 6 first. So when we're solving for number 6, we look at all the possibilities that we have. Okay? As I told you earlier, number 1 is we find the number of slots. Okay? So for the artist, we gave 1 slot. Okay? So 1 slot for the artist. How many artists are there? There are 6 artists. Okay. How many slots for the designer? Also 1. How many slots? How many choices for the designer? There are 4 designers. And then for the writer, also 1 slot. How many writers? We have 3 writers here. Okay. So 6 combination 1, 4 combination 1, 3 combination 1. This will just be 6 times 4 times 3. Okay. 6 times 4 times 3, that is 72. And finally, the probability of this one, probability of number 6, again, this is just the number of outcomes that you want, 72, divided by all the possible outcomes, which is here. This is all outcomes. Okay, this is all the possible outcomes. So this is 286. Okay, so in our calculator, this should be 286. In fraction, it is 36 over 143. In decimal, This is 0.2517. Okay, that is our answer to number 6, getting one artist, one designer, and one writer. Okay, let's move on to the next problem. Okay, you're free to pause the video and then replay it because I need the space. I need to delete this once. Okay, so here, let's try selecting no artist. This is not number 6. Okay, this is actually number 7. Okay, so when we select no artist, okay, so okay, that means that all the 3 spaces, okay, we still make 3 spaces. This is still a combination problem. The, the difference now is that we will not count the 6 artists, okay? They will not be counted because, again, that is our condition. There are no artists with this particular problem. So we remove the 6 here. If we remove the number 6 here, we are left with 4 designers and 3 writers. So this is 4 plus 3, which is basically just 7. Okay, so 7 combination 3, which is equal to, okay, so 7 combination 3, that is equal to 35. Okay, and then of course we need to find the probability of this one. The probability of E is equal to the number of outcomes that you want divided by all the possible outcomes, which is 286. Okay, so this one, 35 divided by 286. Okay, this is actually the lowest term already, so I'm just going to give you the decimal. The decimal is 0.1224. Okay, so that is the answer to this particular problem of selecting no artists. Okay, so next problem, selecting a team that is composed of only of artists. Okay, so this is actually an easier one because how many slots do we give to the artist? We give the artist all the 3 slots. And how many artists are there? There are 6 artists in total. There are no 4 designers, there are no 4 writers, so you do not need to think about them. So just all for the artists. Okay, so obviously this is still a combination problem, and 6 combination 3, this is 20. And then to find the probability, this is just the number of outcomes from the event that you want. That is 20 events divided by all the possible outcomes, 286. So in our calculator, this is the lowest term first is 10 over 100, 10 over 143. In decimal, this will look like this. Okay, 0.0699. Okay, so this is the answer, the probability of selecting a team where they are all artists. Okay, so this one is the answer, 10 over 143. Oh, and that's that. Okay, so the last problem here is selecting a team composed of 2 writers and 2 other non-writers. Okay, so how many slots do we give to the writers? We give the writers 2 slots. This is still a combination problem. And how many writers are there? There are 3 writers. Okay, so 3 combinations 2. And then the other one must be a non-writer. So how many slots do we give to the non-writer? We give 1 slot to that one. How many non-writers are there? When we say non-writer, how many of the choices are not artists? Sorry, are not writers. Okay, so we have 6 artists and 4 designers. That means, and then we have not used any one of them. So 6 plus 4, that is 10. We have 10 who are not writers. We give them 1 slot. So this is 3 combination 2 times 10 combination 1. 3 combination 2 is 3. 10 combination 1 is 10, so this is 30. And finally, we get the probability of E, which is just 30 divided by all the possible outcomes, 286. Okay, so putting this into a fraction, the lowest term for this one, okay, it is 15 over 143. In decimal, it will look like this, 0.1049. Okay, so that is the probability of getting a team of two writers and another one which is a non-writer. Okay, so that is the answer to that problem. And that ends this slide. Okay, so let's move on to the next slide. This one is actually a bit harder. Okay, because if you look at it, we are looking for a lead, composer, marketer, and editorial. So I'm going to delete this one. Okay, so how many people are we looking at? One is the lead, second is the composer, third is the marketer, fourth is the editorial. The question is, are these all the same positions? Okay, of course, obviously, they are not the same positions. The lead is different from the composer, composer different from the marketer, etc., etc. Okay, so if it's not the same, okay, if it's looking at different positions, that means we are looking at a permutation problem. Okay, so we'll solve that later. What's important is that we establish that this problem is a permutation. Okay, so the company is composed of 7 males, 8 females, and 2 non-binaries. Okay, so let's establish this first. We have 7 males, 8 female, and 2 non-binaries. That means we have 7 plus 8 plus 2 choices. That means we have 17 possible choices. Okay, 17 different people. Okay, now let's look at S first. What is the number of outcomes when we select without condition? Okay, all the possible outcomes selecting without condition, they are just the same. So you can look at it this way. You can look at it as boxes. Okay, for the first box, for the lead, how many choices do we have? Anyone can be a lead, so we can have 17 choices. For the composer, of course, the one we selected for the leader cannot be selected again here. So the 17 choices will now become 16 because the other one is already selected for the leader. And then the third one is 15. The fourth one is 14. Okay, because again, you assign each member to the positions, meaning you are getting a decreasing number of candidates per position. Okay, so the number of choices that we can have here is, okay, 17 times 16 times 15 times 14. So the answer there is 57,120. Okay, this is all your possible outcomes. Okay, so we move on to the items here. Let's start with item number 10, having an all-male team. So since they are all male, okay, again, we're still looking for 4. Okay, we're still making a team of 4. So how many males do we have here? We have 7 males. Okay, there are 4 slots, all of the males. So on the lead, I can have 7 choices. For the composer, 6. For the marketer, 5. For the editorial, 4. So 7, 6, 5, and 4. Actually, you can put this as in your calculator as 74 because 7 males, 4 slots, and then a permutation problem. So 74. Okay, or whatever is more convenient for you. For me, this one is more convenient. This boxes. Okay, because it has a logical explanation rather than just putting in the calculator. Okay, so this one is 840 possible outcomes. Okay, and to get the probability, again, it's still the same. The probability is just the number of events that you have divided by all the events, 57,120. Okay, so let me just put this in my calculator. Okay, this is, the lowest term here is 1 over 68 in decimal. This is 0.0147. Okay, this is the answer to number 10, or this problem where you have an all-male team. Okay, again, this one is the male because 7 males, 4 slots. Okay, 7 on the first, 6, 5, and 4. Okay, next, we move on to this problem, having a female lead while the rest are males. Okay, so let's try the condition first. Okay, the event that we are looking for is that we want a female lead. Okay, so female. Now, how many females do we select from? Okay, as you can see from above, we have 8 females. So for the lead, we have 8 possible choices. And then the rest are all males, meaning this one is a male, this one is a male, this one is also a male. How many males do we choose from? Of course, we have 7 males here, 7. Okay, so we put here 7. Now, for this slot, how many males do we have? Do we still have 7? Of course not, because we used one male here. So this one, we only have 6. And then this one, we only have 5. Okay, so this one is 8 times 7 times 6 times 5, which is 1,680. Okay, and of course, to find the probability, we get the number of events that we have, 1,680, divided by all the possible events, 50,120. Okay, so that we can get 1 over 34. So in decimal, this will look like 0.0294. Okay, so this one is the answer. The probability of getting a female lead while the rest are all males. Okay, so next problem. Okay, this one is having a non-binary editorial and composer. Okay, so let's try that one. Okay, so oops, for E, we get a 1, 2, 3, and 4. How many non-binaries are there in the problem? There are 2 non-binaries here. Okay, the editorial and the composer, the second and then the fourth. So this is a non-binary. For the editorial, we have 2. And for the composer, of course, we only have one choice here because the first non-binary was put as the editorial. Okay, so this one for the composer, there's only one. For the rest, there are no restrictions. Okay, because there are no other conditions, meaning we can put anyone else that remains here on the following slots. Okay, so out of the 17, we already used 2 members, the 2 non-binaries. That means for the lead, we have 15 choices. For the marketer, we have 14 choices. Okay, so and then you put this in your calculator, you will get 420. Of course, the probability of E is just the number of events that you want, 420, divided by all the possible events. Okay, 420 divided by 57,120. The lowest term is 1 over 136. Okay, and then in decimal, okay, let me just check. Okay, in decimal, this is 0.0074. Okay, 0774, rounded up to the 4 decimal places. Okay, this is the answer to having a non-binary editorial and composer. Okay, so we move on to the next problem. Okay, the next item. Okay, we have a team that is composed of not female or no female on the team. Okay, so for this case, we have no female. That means we are going to look only at the males and the non-binaries. So there are 7 males and then 2 non-binaries. That means 7 plus 2. We have 9 choices for the lead. Then, of course, we are decreasing because we assign one slot, one person per slot. So the second slot will only have 8. Then the next one will have 7. The next one will have 6. Okay. So 9 times 8 times 7 times 6. Why is it 9 again? Because this is just the number of males plus the number of non-binaries. Okay. So that is 7 plus 2, which makes it 9. Okay. So put this in the calculator. We get, okay, 3024. Oh, 3024. Of course, final step, the probability is again the number of outcomes we want, 3024, divided by all the possible outcomes, 57,120. Okay, put this in the calculator. You will get the lowest term, which is 9 over 170. So in this case, 9 over 170, the decimal is 0.0529. Okay, so that is the answer when you're looking for a team with no female. Okay, so the last item or the last problem for this slide, oops, we have a team composed of only females and non-binaries. Okay, so we're looking at only females and non-binaries. Okay, how many females are there? There are 8. How many non-binaries are there? There are 2. Okay, so that means for the lead, we have 10 people. For the next slot, we have 9 because we used the one person for the lead. Of course, 9 will be here. And then 8 choices and then 7 choices. Okay, so the number of outcomes for this one is just 5,040. So why did we begin at 10 again? We began at 10 because there are 8 females plus the 2 non-binaries. Because we want a team that is composed of only females and non-binary. 8 plus 2. That's why we got 10. Okay. So to get the probability, again, okay, oops, we get the number of outcomes that we want divided by all the possible outcomes. Put this in the calculator. And then the lowest term will be, okay, this will be 3 over 34. In decimals, this will be 0.0882. Okay, so that is the answer to this particular problem. Okay, having a team consisting of only females and non-binary. Okay, so we move on to the next slide, the final slide actually. Okay, the final slide here is that we have the word Yggdrasil. Okay, so as you notice, each of the problems are looking at the different number of letters. Okay, so we can't just solve for the rearrangement of Yggdrasil because of the items are of different length. Okay, so what we can do here is that we can identify how many vowels and how many consonants are there in Yggdrasil. For in this case, for consonants, okay, we have how many? We have Y, G, D, R, S, and L. So that is 6. For vowel, we have 2, which is only A and I. And then let's put that total letters. Total number of letters is obviously 8 letters here. Okay, let's keep that in mind. Okay, so let's first solve number 15. getting a four-letter arrangement. Okay, so let's find S first. How many four-letter arrangements could we have with the letters Yggdrasil? So one, two, three, and four. Okay, so all the possible outcomes is without condition, meaning you can put any letter on the first slot and then so on and so forth as you fill in the rest. Okay, so this one, of course, no restriction. I can have eight choices for the first letter, and then seven, and then six, and then five. So our S is 8 times 7 times 6 times 5. I think we have solved this earlier already. This is 1680. 1680. Okay. Now, what is the event that we are looking for? The event that is following the condition. What is the condition? The condition is it starts with a vowel and ends with a consonant. So one, two, three, and four. Okay. It must start with a vowel and it must end with a consonant. Okay, so how many vowels are there? We have two vowels. Okay, so two here. How many consonants are there? We have six consonants. Okay, and then what happens to this two? What happens to that two is you can fill in the rest. Okay, these are without conditions. Okay, so how many letters are left? We have already filled the first slot and the second slot, which means out of the eight letters, we have already used two letters. So 8 minus 2, we have six letters left for the second letter and obviously five letters for the third letter. So put this in the calculator. Okay, you will get 300, oops, 360. Okay, and finally, to get the probability of E, that is just the number of events that you want, divided by all the possible events. Okay, the lowest term for this one is 3 over 14. And in decimal place, this is okay, 0.2143. Okay, this is the probability of getting a arrangement, four-letter arrangement, starting with a vowel and ending with a consonant. Okay, next one. Okay, the next one, we are getting a three-letter arrangement. Okay, so three letters, one, two, and three. Let's find those without condition first. Without condition, I have eight choices for the first letter, seven for the second, and six for the third. Okay, so 8 times 7 times 6, that is 336. Now, let's look at our event, the event that we are looking at. The event that we are looking at here is only consonant. That means for E, all the three letters must be consonant. So for the first slot, how many consonants do we have? We have six. Okay, so I have six choices here. For the second letter, how many choices will I have? I will only have five because I already used one consonant for the first letter. So the second letter will only have five choices. And then the third letter will have four choices. Okay, so putting this in the calculator, you will get 120. And of course, the probability of E, this is equal to the number of events you're looking at over all the possible events, 336. Okay, again, reminder that S is all the possible events. These are all without oh, sorry. This is without condition. Eh, sorry. Okay, that's just that. Or all or without condition. Okay. So the lowest term for this one, 120 over 336. That is 5 over 14. In decimal, this is 0.3571. Okay, so there's that. Okay, next problem. Okay, for the next problem, we are getting a full rearrangement. That means we're going to use all the letters. Okay, so it can be a bit long. Okay, so all the 8 letters, 1, 2, 3, 4, 5, 6, 7, 8. Of course, for the first letter, I have 8 choices. For the second letter, 7, 6, 5, 4, 3, 2, 1. Now, if you want to put this in the calculator, you can just put 8 factorial. If you're going to use all of them, just put 8 factorial. It will be the same. Okay, so 8 factorial, this is 40,320. Okay, now for the event that we want, okay, of course, this is also 8 letters, 4, 5, 6, 7, 8. But what we want is that it starts and end with a consonant. So it starts with a consonant, it ends with a consonant. Okay, so how many consonants do we have? We have 6 consonants. So for the first letter, I have 6 choices. For the last letter, I only have 5 choices because I used one choice. Now, how many letters have we used? We already used 2 letters. So how many letters do we have remaining? From 8, we used 2. That means we have 6 letters for the second letter, then 5, then 4, then 3, then 2, then 1. Okay, so put this in the calculator if you want. Okay, so in the calculator, this is 21,600. Okay, let's put that here. Oops. Okay, of course, to find the probability of E, this is, again, the event that we are looking at, 21,600, divided by all the possible events. Okay, putting this in the calculator, we will get, okay, the lowest term is 15 over, oopsie, 15 over 28. Oops. In decimal, this will look like 0.5357, rounded off to 4 decimal places. Okay, so that is the probability of getting a full rearrangement that starts and ends with a consonant. Okay, so the last problem with the slide here. Okay, we get a 5-letter rearrangement. Okay, let's start with S first. S is the 5-letter rearrangement, 1, 2, 3, 4, and 5. And S is without condition. So I can choose any letter for the first. So that is 8, 7, 6, 5, and 4. So putting this in the calculator, we get 6,700, 6,720. Okay. And then for E, okay, the event that we are looking for, look, this is actually a bit hard. The first 3 letters are consonant. Okay, fine. 1, 2, 3, 4, still 5. The first 3 letters are consonant, so consonant, consonant, consonant. And the last letter being a vowel. So this last letter is a vowel. Okay? So how many consonants are there? Again, there are 6 consonants. So this one, 6. Of course, this one will only have 5 because we have already used one consonant. This one will be 4 because we have used 2 consonants already. Vowels, how many vowels have we used? None. How many vowels are there? There are 2 vowels here. Now, how many letters have we used already? First, second, third, and fourth. So 4 letters. Out of 8, we used 4. That means for this last slot, we have 4 different choices. Okay? So put this in the calculator. Okay? We will get 960. And of course, the final step, the probability of E is equal to the number of outcomes that we want, the number of outcomes that satisfy the condition divided by all the possible outcomes. So putting this in the calculator, you get, oh, it's actually high. It's 1 over 7. And 1 over 7 is, in decimal, 0.1429. Okay, so that is the answer to this final item in our quiz. Okay, so again, remember, it's always just the number of outcomes that we want, the number of outcomes in the condition, divided by the number of all possible outcomes, or the number of all outcomes without condition. Okay, it's always just that. Okay, you just have to read the problems carefully. So that is all for this recording. I hope this will help you ace your exam and your other endeavors for this class, and good luck to all of you.